Alright, last section in chapter 4, exponential and logarithmic equations. Alright, we're going to see how to solve equations. And there's several different ways to do it here, and it all is based upon the setup of the way the equation looks. Alright, so if you have an equation where you have exponentials, and you have an exponential is equal to an exponential, and they have the same base, alright, or if you can rewrite it so that they have the same base, you can drop the exponents and get drop the bases and just set the exponents equal to each other. All right, so let's look at how that would work. All right. On example 1, okay, I've got 2 to the 3x minus 8 is equal to 16. All right, now I can actually rewrite that 16, since that is a power of 2, I can rewrite that as 2 to that power. And so that's 2 to the 4th. 2 times 2 is 4, times another 2 is 8, times a fourth 2 is 16. So I can rewrite that with the same base, and once I have the same base, I can drop the base, and I can just say the exponents are equal. 3x minus 8 is equal to 4. And now I can solve for that x. So if the bases are the same, you can drop the base. And set the exponents equal to each other. Now you solve this out like a normal linear. Add the 8, so you get 3x is equal to 12. Plus 8 plus 8. And then divide by the 3. You get x is equal to 4. Alright, for b, I've got two exponentials. They have different bases, but they're both powers of 3. So I could rewrite 27 as 3 to the 3rd raised to the x plus 3. And I can rewrite 9 as 3 squared to the x minus 1. Alright, and then when I raise power to a power, this turns out to be 3. When I raise the power to a power, I multiply, so that's become 3x plus 9. I multiply that power to the x and the 3 is equal to 3 to the 2x minus 2, because I multiply the 2 and the x minus 1. Now I drop the base. I drop the base, I end up getting 3x plus 9 is equal to 2x minus 2. So since the bases are the same, I can drop them. And then I solve out that equation. Subtract the 2x over. So I get x plus 9 is equal to negative 2. And then I subtract the 9. I get x is equal to negative 11. Alright, see if you can do that. Remember, rewrite the bases as the same if you can. Alright, and then once you get them, you can drop the bases and set the exponents equal to each other. Alright, pause it. Alright, here you go. Here are the answers. Alright, this will be 5 to the 3x minus 6 is equal to 5 to the 3rd. You can drop the base and get 3x minus 6 is equal to 3. Add the 6 over. 3x is equal to 9. Divide the 3. X is equal to 3. On B, I'm going to have 8 is 2 to the 3rd to the x plus 2. Alright, and 4 is 2 squared to the x minus 3. Alright, that'll turn into 2 to the 3x plus 6 is equal to 2 to the 2x minus 6. So you end up dropping the base to get 3x plus 6 is equal to 2x minus 6. All right, if you subtract the 2x over, you'll get x. Subtract the 6 over, you'll get negative 12. All right, and so that is how you solve exponentials when you can rewrite the base as being the same. All right, now if you cannot write the base as the same, all right, you can isolate the exponential expression and take the common log if you have a base 10 or natural log if not. Doesn't really matter. All right, and then you can use the power rule to get the exponent out and then solve. So let's just show you how to do these. All right, so I've got 4 to the x power is equal to 15. 15 does not have, is not the answer to any power. Okay, so you can't do it with that last way. So I'm going to have to use this new method. So I'm going to write the natural log of the 4x, 4 to the x, is equal to the natural log of 15. All right, now, so just put a natural log in front of both sides. Now I can bring the variable out front using that power rule. This becomes x to the natural log of 4 is equal to the natural log of 15. All right, that's the whole reason why we use this, so we can bring that variable that's in the exponent out front. And then now I just need to get x by itself. So since that's x times natural log of 4, I can divide by natural log of 4 on both sides. So that gives me x is equal to the natural log of 15 divided by the natural log of 4, which that is the exact answer. Okay, but then I can put that in my calculator to get an approximation. And so the natural log of 15 divided by the natural log of 4. Put that in my calculator. That gives me approximately 1.953. All right, so either on a test or on MyMathLab, make sure you see how they want the answer written. If it's a decimal approximation, put it in your calculator. If not, leave it as natural log of 15 divided by natural log of 4. All right, for B, all right, 120,000 is not 10 to a power. Okay, so I can either use natural log or I can use common log. Since it has a 10, I'm going to go ahead and use the common log. So the common log of 10 to the x is equal to the common log of 120,000. All right, which the reason why I use common log is because the common log of 10, those cancel themselves out. I'm just left with x. And so my answer is x is equal to the log of 120,000. Okay, so if the base is 10, you can use that common log and you're done really, really quickly. And if I stick that in my calculator, I get that answer is 5.079. Now, you could use natural log on this one. Okay, you could write this as the natural log of 10 to the x is equal to the natural log of 120,000. All right, bring the x out front like we did in example A. And we get x times the natural log of 10 is equal to the natural log of 120,000. And then divide the natural log of 10 over. And so the natural log of 120,000 divided by the natural log of 10 is going to give you exactly the same decimal as a log of 120,000. Okay, it's just easier if the base is 10 to use the common log. All right, pause it, see if you can get the next one. All right, your answer for this one is going to be the natural log 134 over the natural log of 5. All right, and then for b, we're going to have the log of 8,000. All right. Now, if you've got more stuff in it than just an exponential and then equal to a number, we want to get the exponential by itself. So before I do the whole log thing, I want to get the e part to it by itself. So I add the 3 on each side. So I get 40e to the 0.6x is equal to 240. All right, then I'll divide the 40 over to get e to the 0.6x is equal to 6. And then I'll take the natural log on both sides. The natural log of the e and the natural log of the 6. All right, on this one it's nice because we have a base of e, so the natural log and the e cancel themselves out. All right, and I'm left with 0.6 x is equal to the natural log of 6. So to get the x by itself, I just divide by the 0.6. I get the natural log of 6 divided by 0.6. And you can stick that in your calculator and get an approximation. All right, try the checkpoint. All right, so let's find the solution and obtain a decimal approximation. All right, so I'm going to add the 5 over, which will give me 63. I'll divide the 7 over, which gives me 9. I'll take the natural log on both sides. The natural log and the e cancels themselves out, so I get 2x is equal to the natural log of 9. And so x is equal to the natural log of 9 divided by 2. I go to my calculator. Natural log of 9, close parentheses, divided by 2. And the 2 decimal places, this gives me approximately 1.10. My decimal is 1.098. The 8 would make the 9 go up. And since the 9 goes up to 10, it's 10. All right, these are the worst type of exponentials. All right, we got exponential on both sides. All right, so I'm going to take the natural log of both sides. This turns into the natural log of 5 to the x minus 2 is equal to the natural log of 4 to the 2x plus 3. All right, now I can bring the powers out front. Since the powers are binomials, I'm going to have to put them in parentheses. So this becomes x minus 2 times the natural log of 5 is equal to 2x plus 3 times the natural log of 4. All right, since we have the parentheses, we do need to make sure we distribute so we can get to the x's. So we have x times the natural log of 5 minus 2 times the natural log of 5. All right, and then on the right-hand side, I'll have 2x times the natural log of 4 plus 3 natural log of 4. All right, once you get all of that distributed through, okay, you want to get all your x terms on one side and all the terms without the x on the other side. So I'm going to move the 2x over to the left. So I'm going to have the x times the natural log of 5. When I bring the 2x over, it's going to become minus 2x natural log of 4. All right, and then I'm going to bring the other term that doesn't have a natural log to the right-hand side. The right-hand side already had 3 natural log of 4. I want to bring the 2 natural log of 5, so it's going to add over and become plus 2 natural log of 5. So I would bring the x's to the left, the non-x terms to the right. Once you have that, you're going to factor the x out of the terms that have x's, so that if you factor the x out, you'll be left with natural log of 5 minus 2 natural log of 4. And then rewrite the other side. And then the last step is to get the x by itself. So you're going to divide that parentheses over. So your answer is going to be 3 natural log of 4 plus 2 natural log of 5, all divided by the natural log of 5 minus 2 natural log of 4. Okay, a lot of work there. Put your natural log in front, bring your power out front in parentheses, distribute, move the x terms to the left, the other terms to the right, factor out the x, and divide the parentheses. All right, try the next problem. All right, so we can have the natural log of 3 to the 2x minus 1 is equal to the natural log of 7 to the x plus 1. Bring the powers out front. So 2x minus 1 times the natural log of 3 is equal to x plus 1 times the natural log of 7. Distribute 2x natural log of 3 minus 1, or minus just the natural log of 3, is equal to x natural log of 7 plus natural log of 7. Bring the x terms to the left. So the 2x was already over there. I'm going to subtract the x natural log of 7 over there. That came over. And then the natural log of 3 will go over here. So I already had the natural log of 7. And I'm adding the natural log of 3 over. Oh, forgot the x here, my bad. All right. Factor out the x. So I got x, 2 natural log of 3, minus natural log of 7. Oop, that looks horrible. Natural log of 7 plus the natural log of 3. And then divide the parentheses over. So natural log of 7 plus the natural log of 3 over 2 natural log of 3 minus the natural log of 7. All right, just have to take some practice on those. Take a little while. But again, natural log in front, bring down the powers as parentheses, distribute, collect x's to the left, other terms to the right, factor out the x, divide the parentheses over. All right, example 5. We have something that looks, we've talked about somewhat before. This is quadratic in form. All right, we have e to the 2x and e to the x in the middle. So this is going to factor out like a quadratic, hopefully. All right, but instead of having x and x, we're going to have e to the x. So we'll have e to the x and e to the x. All right, but the factor like a quadratic is what multiplies to give me 3 and adds together to give me negative 4. Turns out that's going to be a minus 1 and a minus 3. Okay, negative 1 times negative 3 is positive 3. Negative 1 plus the negative 3 gives me the negative 4. Okay, so it's going to factor out like a quadratic. You just have e to the x in both spots. And then you'll set each parentheses equal to 0. So if you do that, you get e to the x minus 1 is 0. Then we'll rework, isolate the radical, or excuse me, isolate the exponential. And then you can take the natural log of both sides. Natural log of e to the x is equal to the natural log of 1. Natural log of e cancels out, I'm left with x. And then the natural log of 1 we've talked about in a previous section is 0. So 0 is an answer. And then e to the x minus 3 is equal to 0. We add the 3. We get e to the x is equal to 3. We take the natural log of both sides. And since the e cancels out and the natural log cancel out, I'm going to get x is equal to the natural log of 3. Alright, so if you see one that has an e to the 2x and an e to the x, it's going to factor like a quadratic and then solve each part out. Alright, pause and try the checkpoint. Alright, that would factor into e to the x minus 7, e to the x minus 1. Alright, so you have e to the x minus 7 is equal to 0. That will give you e to the x is equal to 7. And then if you take the natural log on both sides, you end up getting x is equal to the natural log of 7. That's one of your answers. You can put in your calculator if you need to get decimal. And then e to the x minus 1. We add the 1 to get e to the x is equal to 1. And anything to the 0th power is 1. So x is equal to 0 is our second answer. All right, now how to solve logarithms. All right, if you only have one single log is equal to a number, you can rewrite it as an exponential. Okay, and then you'll be able to solve for the variable. Okay, you do need to check on these to make sure the actual answer works. Okay, because sometimes you might get an answer where when you plug it back in, the argument is not positive, which it has to be positive. Okay, so we have to check. All right, so example 6a. All right, since we have a single log is equal to a number, I can rewrite this as the base is equal to, or base to the number power over here, the 2, is equal to the argument. This goes back to when we learned about logarithms in section 4.2. Okay, the base to the power is equal to the argument. And so that gives me 16 is equal to x plus 3. Subtract the 3 and I get x is equal to 13. Alright, I double check, I plug it in. 13 plus 3 is 16. Since that argument's bigger than 0, I'm good. Alright, for b, I need to get that log by itself. So I need to get rid of the 3 first. So if I divide the 3 over, this gives me the natural log of 2x is equal to 4. Now I'll rewrite it as an exponential. Since a natural log has a base of e, this will be e to the number by itself, power, 4, is equal to 2x. And then I divide the 2 over, I get x is equal to e to the 4th divided by 2. All right, and since e to the 4th is positive and so is 2, when I multiply that by the 2, I am going to get a positive inside there. All right, try your checkpoints. All right, for A, the answer is going to be 12. And for B, the answer is going to be e squared divided by 3. All right, this just talks about having that negative on the inside. You can't have the negative number or the logarithm of 0. All right. So example 7, we've got 2 logs, okay, and then a number. But we can use our properties to make this work. We want to get the logs together. Since it's a plus on the outside, this can become a multiplication on the inside. So this becomes the log base 2 of x times x minus 7 is equal to 3. Addition on the outside, multiplication on the inside. So now we have a single logarithm. We can write it as exponential. 2 to the third power is equal to x times x minus 7. All right, 2 to the third is 8. I'll go ahead and distribute here to get x squared minus 7x. Since it's now quadratic, I can move the 8 over and get 0 is equal to x squared minus 7x minus 8. And then I factor. All right, what multiplies to give me a negative 8 and adds together to give me a negative 7? Turns out it's going to be a minus 8 and plus 1. And then I'll set each of those equal to 0. I end up getting 8 as the answer choice. And then x plus 1 is equal to 0. I subtract the 1, I get x equals to negative 1. All right, but when I check it, the 8's going to work. If I put an 8 in here, that's positive. If I put an 8 in here, 8 minus 7, that's still positive. So 8 definitely works. But if I try to plug the negative 1 in, the log base 2 of negative 1, the argument in here cannot be negative. It can't be, it has to be positive. So negative 1 is an extraneous solution. It does not work. All right, try your checkpoint. All right, this becomes log, common log, of x times x minus 3 is equal to 1. Since the base is 10, this becomes 10 to the first is equal to x times x minus 3. All right, that's 10 is equal to x squared minus 3x. I subtract the 10 over. X squared minus 3x minus 10. I factor. Comes x minus 5x plus 2. I set those equal to 0. This gives me answer choices of 5 and negative 2. The 5 will work. 5 and 5 minus 3 is 2, so that works. All right, negative 2 though, no, it makes that negative, so then negative 2 does not work. All right, and then finally, the one-to-one properties of logs. Okay, if you end up with a log is equal to a log, you can drop the log and solve for the variable. All right, so for example here, I've got natural log minus natural log equals natural log. All right, first thing I can do is I can put the left side together because there's a minus. This becomes the natural log of the first argument divided by the second argument. All right, and now that I got log is equal to log, I can drop the log. Okay, I can drop the log, just kind of like I did with the exponentials. If I had exponentials that were the same, I can drop the base. If I have logs that are the same, I can drop the log. And so this ends up giving me x plus 2 divided by 4x plus 3 is equal to 1 over x. And I've got to solve from here. Since I've got a fraction is equal to a fraction, I can cross multiply. which means take the numerator of one and multiply it by the denominator of the other. So that'll give me x times x plus 2. And then take the denominator and multiply it by the numerator, and that gives me 4x plus 3 times the 1. I'll multiply out x squared plus 2x is equal to 4x plus 3. All right, I bring everything to one side. So if I subtract the 4x, that's 2x minus 4x is going to give me a minus 2x. Go ahead and write that there. Subtract the 3 over as well. So minus 3 is equal to 0. I factor it. X minus 3, x plus 1. So my answer choices are 3 and negative 1. I go back up to my problem though, because I got to make sure it actually works. The 3 plus 2 is 5, 4 times 3 is 12 plus 3 is 15. 1 divided by 3, all those are positive, so that one works. If I throw the negative 1 in, negative 1 plus 2 is 1, that's fine. 4 times negative 1 is negative 4 plus 3. That's negative, so the negative 1 does not work. The answer is just going to be the 3. All right, see if you can do that last checkpoint. So pause it out. All right, here we go. I'll end up having the natural log of x minus 3 is equal to the natural log of 7x minus 23 over x plus 1 because of the minus. I can put those together. I can now drop the logs. So x minus 3 is equal to 7x minus 23 over x plus 1. All right, I can treat like there's a 1 under here, so I could cross multiply. I'd end up getting x minus 3 times x plus 1 is equal to 7x minus 23. If I multiply that out, that's going to give me x squared minus 3x plus 1x minus 3. Get everything to one. Well, let me go ahead and become x squared minus 2x minus 3. Now if I bring everything to one side, subtract the 7x, it'll become x squared minus 9x. Add the 23, that'll become plus 20. And that's going to factor into x minus 5, x minus 4. So I've got x is equal to 5, and x is equal to 4. 5 minus 3 is 2. 7 times 5 is 35 minus 23. That's fine, that's positive. 5 plus 1 is positive. 4 minus 3 is 1. 4 times 7 is 28. Minus 23, still positive. Yeah, both of those answers work. All right, a lot of stuff in this one. It's going to take a lot of practice. Do the My Math Lab and email me if you got questions.